What are the important principles in designing an effective relational model? How do we do it? Hi, this is Jerry. Thank you for visiting this vlog. Watch this. Relation is a two-dimensional, row and column table or data. Not all tables are considered relational. The following properties should be our basis to determine if a table will pass on a relational criteria. Let us discuss each one. Each column should have a single value. On our patient table, we have date visit, physician, and symptoms column in two values. To convert the table into a relation, we split John into two to get rid of the multi-valued columns. On our second property, when we set our column to handle a specific length or type, we follow it with a specific format. We may limit the length or entries that may not suit the format of the column. Patient number and date visit are good examples to show this. Each row is unique. One may say there are redundancies on our given table, but it is not. Applying also property 1 that each column should have a single value, the existence of John still differ if we combine columns patient number and date visit. One of the most important you need to do in making any table into a relation, primary key should be set. All tables that are set to be maintained should have a primary key. Rearrangement of columns and rows does not change a relational table. We may set our rows in descending or ascending order. We may show only columns we need on a specific presentation. Still, our table is in relational type. One of the interesting aspects when designing a relational table is functional dependency. Simply put, functional dependency exists when you're trying to ask the relation among attributes in a given relational table. Knowing the key where attributes depend upon, it will lead you to determine other attributes or column data that depends on that specific key. Knowing the social security number of a person will show other data that depends on that SSS number. You can determine the address, occupation, employer, etc. after keying in the SSS number. Let us discuss this with an example. On our given problem, in order to know the other specifics of each row, we identify patient number first. We say name and address are functionally dependent on patient number. Therefore, we enclose our annotation with the name of the table and underline our primary key. On our next example, how do we set our functional dependency notation and establish our primary key? We say grade is not dependent on student number but also on subject code. When one attribute depends on other attributes, we call this a composite key. Why does composite key exist? If grade is just dependent only on subject code, does it make sense? Knowing subject code and grade does not help much. In order to appreciate our data, we should know who earned a grade on a particular subject. Knowing the student number will now help us to determine the student who got a grade on that particular subject. How about if grade is dependent only on student number? Will that help much? Knowing the student number won't help, because the next big question is, he earned a grade on this, but on what subject? See the picture? So on our example, we need the two key attributes to know the existence of our grade column. Therefore, we set our composite key as primary key. The next question is there a column or attribute which depends only on one key attribute? Our example will help us understand the meaning of partial functional dependency. Let us check our table and derive our functional dependency notation. Name, department, and salary are all dependent on employee ID, while training date is dependent both on employee ID and training. Having identified our dependency, we have on our relation a primary key, a combination of employee ID and training. But name, department, salary are all dependent only with employee ID. We call these three partial dependents. To remove partial dependency, we split our existing tables into two new relations. Here on our example, we created personnel and trainings. Note that we have just followed the functional notation on what we have set earlier and created new names for our new tables. So what do you think our new tables look like? Let us check the split up. As you could see, we have new set of tables, personnel and trainings. Since in our rule, on all relations, each row should show uniqueness and each table should consist of its own primary key. On personnel table, IV goodings exist once only. See the effect of the split up?